Hi everyone, great to have all of you here. What's new in Web AI? That's the title of this talk, and thanks also to our awesome MCs because you said everything that is relevant. So I'm a member of the WebML Working and Community Groups, and I'm also leaving shortly after this talk here, heading to Japan, where the annual meeting week of W3C will take place. So if you have any feedback after this session, come and find me, because it's always very important for standards bodies to know what you as developers think, so that standards bodies can build the right things for you. Yeah, why should you care about AI as developers? Here's a great quote from Mathieu Riegler some couple of weeks back. We had a great meetup in Graz, and he did a session on AI, and that was his opener, I think, that AI is all about the new possibilities. Don't try to solve stuff that could be solved with an if statement, right, or a for loop, and just continue to do that rule-based stuff, continue to use rule-based algorithms for purposes where it makes sense. AI is not like the magic solution for everything. Use it where you can make added benefits for your users, where you can improve user experience, where you can make their lives better for your users. Now, usually when you want to integrate AI into your applications, typically you would go to some of these examples here, some of the cloud providers here. The list is not exclusive, of course. However, there's a tiny issue with those cloud providers. Actually, there's not one tiny issue, but many tiny issues. The first one is that if you want to do inference in the cloud, of course, obviously, you need to have a stable internet connection. When I'm on the plane tomorrow, I will likely not have this stable internet connection. So if I would like to code on the plane, for example, I don't get any Copilot suggestions, for example, if we only had cloud-based models. Then it's all subject to network latency and server availability. So basically, especially at the start of ChatGPT, there were the server limits, right, where the servers were at capacity, and there was no inference for you. Pretty bad. Also, you are creating a dependency on that particular cloud service, right? You've used the OpenAI SDK, and now somebody else comes around and has a better model, better SDK. Well, then rewrite your AI inference pipeline, right? Because you built it to depend on that particular service. Most importantly, I guess, is that data is transferred to an external service. It leaves basically your control. You may have to sign a contract with the provider. The provider might have to be in a certain geographic region and so on. And also interesting, you might have to buy a subscription, because usually you pay per token, and so you have to pay for AI inference. And that's the drawbacks of those traditional cloud providers that we currently use in most cases. And so the question is, can we make it better? Can we improve the situation? And the answer is, yes, we can. This is the Web AI landscape. What is Web AI? It means AI done on the web platform, typically right in your browser. And there's two main methods to do this. One is bring your own AI. Here, you use a library or a framework and download your own model, the exact model you want to use, to make sure it matches your expectations regarding response quality and capabilities. Then there's Web Platform APIs to do that model inference on the web, WebGPU, WebNN, and then there's a new API called Cross-Origin Storage that I will present you today. On the other hand, we have the built-in AI approach, and here we use a model that is already present on the device or on the operating system. And here we have writing assistance APIs, summarizer, writer, rewriter, and new, the proofreader API. There is the translator and language detector APIs, and the prompt API with new multimodal and inputs and structured outputs. And then there's WebMCP, also very interesting. And I will show you all of those new APIs. Okay, number one, WebLLM. This is a library where you can do LLM inference right in your browser. Let me quickly show that to you. I will go here in Chrome, went to the WebLLM website, and now I will kill my internet connection. Boom, I'm offline. And now I want to do AI inference. And I can ask stuff like, what is the capital of Germany? Spoiler, it's Berlin, so the city that we are at. And you see it all works, although I am offline. Inference has taken place right here on this machine. And so basically whatever you ask, nobody else will see it. No reviewer at ChatGPT or Gemini or whatever, or Microsoft Copilot will ever see what you've written there. It's all private. It's all happening right on your device whenever you want. If you want to integrate WebLLM into your applications, it's pretty easy. They have a great NPM package that you can simply download and add to your Angular app. I did that here. In the next example, I added a chatbot functionality to a to-do list application written in Angular. Important note, nobody is surprised by chatbots anymore, right? That's like super lame. So this is one example of how to use WebLLM, but don't expect your users to be surprised when you add your chat box to something that didn't have one before. It's like stories. Right? When stories started to appear everywhere, it's like the same with chatbots. All right. So here I have my great application. Also, it uses WebLLM, right? And now I can add to-dos. Let me say I need to pet the dog, and I need to clean my car. And now you can do LLM inference, and you can ask questions regarding your to-do list. Like, for example, how many to-dos do I have? And same principle, right? It would also work offline. And now I have 2 to-dos, that's right. How many open to-dos do I have? Should be 1. 1 open to-do, clean my car, it's true. Write a poem about my to-dos. Okay, the task is done with joy so bright, petting the dog a happy sight. But one task remains, a chore to face, cleaning the car, a necessary pace. Okay, interesting. Yeah, so that's also possible. You can do whatever you want. What LLMs can normally do, right? Translate between languages, extract it to a certain format, come up with new to-do ideas. Basically, the standard stuff that you could do with LLMs. Okay, how does it work? WebLLM needs to download the model that you select before doing inference. And it does so by utilizing the cache API that was introduced as a part of the PWA APIs back in the day. It can be used to store your HTML, JavaScript, and CSS files to make your web app offline capable. But it can also be used to store arbitrary files. And in that particular case, we will store the model's weights, the binary files containing the parameters, right on the user's disk. However, there is a small issue. And that is that on the web, we have the same origin policy. This means that we cannot share storage between 2 origins. And that's the combination of protocol, hostname, and port. So example.com cannot share data with example.org. For a good reason, because that's our tracking protection. So nobody can track us across the web. However, large language models are, by nature, pretty large. Even small ones, like the Qwen 3 model with 4 billion parameters here, already start at 2.5 gigabytes. And if we are getting serious, right, so at the bottom of this list, we are even at 67 gigabytes. So if we cannot share memory, that's going to be a problem because our hard disks might fill up pretty quickly. That's for WebLLM. There's another very interesting library or framework, it's sort of in between, and that is called Transformers.js. Let's also have a look at this framework. Transformers.js allows you to run also AI workloads on your system, again, right in the browser, and they support a vast field of AI stuff that you can do, not only generative AI, also other things. And the demo that I like to present here is Doodle Dash. It's also pretty funny. So the AI model has to guess my doodles. And again, offline capable, so I can download this before I board the flight, and then I can draw, okay, peas in that case. Okay, a lobster. Okay, sorry, I give up. A couch. Okay, that should be easy. Skip. A roller coaster. All right. Okay. I guess that's not gonna not gonna work. A seesaw. What is that? I don't know. A saxophone. Okay, that was quick. A foot. Rain. Oh, come on. A birthday cake. All right. Here. Zap, zap, zap. All right. So sorry, I wasn't that good here. In that case, it was only the great saxophone and the awesome piece. It works better sometimes. Well, yeah. Basically, what you can see is you can bring whatever model you like. It does not necessarily have to be a large language model. It can also be, like in that case, an image classification or recognition model that I showed you. How do they pull this off? So WebLLM and Transformers.js. They are both using a web API, a web platform API, meaning that's provided by your user agent, by your browser, called WebGPU. WebGPU gives you low-level access to the graphics processing unit of your device, and that's great for machine learning applications because we can run them pretty efficiently there. WebGPU is supported by all Chromium-based browsers for a longer time already. New, also by Safari 26 on the 26 model of Apple operating systems, and in Firefox 141, at least on Windows. And that's basically the API that allows us to do efficient AI inference. However, it even becomes better. There's another new API called WebNN, and this will not only give us access to the GPU of the device, but also additionally to the NPU, the neural processing unit or the tensor processing unit of the device that is specifically tailored to run AI inference as efficiently as possible. This is currently in specification by the WebML Working Group. It's on a standards track, so this may become, or will likely become, a web standard soon. Implementation is currently in progress. In Chromium-based browsers, you need to enable a flag, and it will help us to make our AI inference even faster. However, WebGPU and WebNN are both abstracted APIs. So they basically talk to the native platform APIs on Windows, on macOS, and so on. And so this means they are an abstraction layer. And abstraction layers always cost a tiny little bit of performance. So what are the drawbacks of bring your own AI? Number one is we cannot share models across origins. So if our 100 Angular apps that we built here in this room, right, all require the same 2.5 gigabyte model, then we will make our disk full, right? So that might be an issue. And inference is fast, but we don't reach the full native speed because of the abstraction layers, WebGPU and WebNN respectively. Let's see how we can fix those two issues. And we will begin with the first one, sharing models across origins. Here's an API that I've drafted together with two people from the Google Chrome team. We call it cross-origin storage. And what it does is it now allows us to share storage between origins. Of course, that can also be dangerous, right? So we don't want to open up an attack vector, a tracking vector. So I want to show you how we address this. All right. So this is our proposal. And basically what we do is there's no file names, so to say, but only hashes. So basically the content of your file that you want to store is also its name. And that way we try to make sure that you basically cannot just arbitrarily create files, right, and use them as a fingerprinting vector. But basically the contents are clear, so to say. We could have like whitelists, for example, allow lists and so on, to only allow certain files. We could block others that we maybe do not want. So all of that stuff would be possible. Currently, this is implemented as an extension. And we have support here by, guess whom, Transformers.js and WebLLM. So exactly the two libraries that I showed you before. And what we did is we built an extension right now because it's for experimenting, right? So this is not going to land directly in Chrome. And here I can now open two origins, WebAI community.github.io and Google Chrome.github.io. And they both want to use the same sentiment analysis model. And now here we have a neat little debug interface. Now I will download the model here on WebAI, and we can see that it's now stored in cross-origin storage. Now we go over to google-chrome.github.io, and now we can reuse the existing model that was put in cross-origin storage. And this would effectively solve the first issue. All right, what else can you do? Last year at NGDE, I showed you a smart form filler that worked using speech, but it has even become better with so-called real-time models. And they really are fun. It's super cool. You can just talk to them in natural language and still call various tools like filler forms, which pages, recognize things, and so on. This is, again, cloud only. And last year, that was the only option that you had. Now we also have like an on-device option. I will show it to you later. Let's first have a look at the full-blown, so to say, cloud solution. Therefore, I will stop this app, go to the other app, and now I can open this one. It's an insurance form, so basically you have to enter info about like a car crash, right, or about the damage of a vehicle. Hi.
Hey there, how can I help you today?
I would like to fill in this form. My first name is Chris. Could you please go to the site vehicle damage? Awesome. Yeah, you can talk to that model also. Here I want to demonstrate something else, the vision capabilities of real-time models, because they can also see. Here I have a car crash image, and now basically it should detect where the damage is, right? And basically fill in the form correctly. So we upload it, and then hopefully the AI model determines that the damage is at the front, which it is, right? And fill that in correctly. And you can chat with them. It's super fun. How are you?
I'm doing great. Thanks for asking.
Okay, say that in Spanish.
Estoy muy bien.
Go back to personal data. Perfect. Yeah, that is real-time models. In that case, backed by the cloud. People are already using this. You can hook it up to your service hotline, for example, and have the AI create tickets for you, or maybe fix or help to fix certain issues. That's all possible with real-time models. The two big ones are by OpenAI, OpenAI Real-Time API, and by Gemini, the Gemini Live model series. So until now, that wasn't possible to do on device. It is now. This one is a demo showcase by Transformers.js. Joshua Lochner, one of the leading people in this area. He built something, but it's not quite as good. So just for expectation setting before I show you the demo. So I think that's here. It's here. All right. So in that case, we are talking to Hart. So let's see.
Hey there, my name is Hart. How can I help you today?
Hart, what is the capital of Germany?
The capital of Germany is Berlin.
Tell a joke.
Why don't scientists trust atoms? Because they make up everything.
Awesome. Yeah, very funny also, this model. And that demo now works entirely on device. And you can still chat with it in this natural way that you've seen. It's actually pretty cool what they do under the hood. They use 4 AI models in parallel. First of all, there's the Whisper model that basically transcribes speech to text. Then there's Celero, a voice activity detection model that basically stops the model from answering once it detects me speaking. Then we use a small language model called SmallLM2 that does the processing, the natural language processing. And then we use Kokoro, which does the opposite way, basically text to speech and then speaks back to me. So, as we can see, it's all possible to also do this kind of interaction on device, which is apparently great for ticket machines, for example, which need additional ways to talk to users, right? If you're blind, for example, this would be great to still allow you to buy a ticket, for example. Okay, that's basically all bring your own AI. Now let's have a look at built-in AI, the second half. And here, in that case, we don't store the model basically in the origins storage, but either as a browser-wide component, or we use the OS level model that may already be present on your device. Gemini Nano is on high-end Android devices, and Apple Intelligence is on newer iOS devices. There's an experiment by the Chromium team again. So it started in Google Chrome, but Microsoft Edge is also on board. And they give us certain APIs to do some experiments. And then they download Gemini Nano for Chrome or Phi for Edge into your browser storage. And then we can also share the model across origins. And we can use native APIs directly. So also we don't have a performance penalty in that case. And here are the built-in AI APIs. And I just want to show you two of them, Prompt API and the new Proofreader API. So this is the website. I will also share the slides with you later. So translating, writing assistance, summary, and so on, Proofreader API, and prompt. Okay, so let's have a look. We just I will do prompt API first. Const language model equals await language model dot create. And then we can say await language model dot prompt. What is the capital of Germany? And then it should answer it's Berlin. And maybe you've seen it. It is pretty fast, right? So the answer is there almost instantly. So that's Prompt API. Again, all running on device using native APIs and also offline capable. What we also have now is the Proofreader API, Proofreader, await Proofreader create. It's always the same principle. Now we can say await Proofreader dot proofread. Here, in that case, hello, my name is Christian. And then it corrects my input to hello, my name is Christian. And even tells me the corrections. You can even turn on a mode where it basically says what the problem was. And then you can, fix your text. That's the built-in AI APIs. Now, also new is support for multimodal inputs. There's nothing new. AI models have already gained vision and also can understand speech. And so, of course, we also had to react on the web. And now Prompt API does also support image input. This one is a very nice demo by the Chrome team where I have to draw again. So be prepared. And I need to draw Mona Lisa. And then basically this art critique will tell me how good I was. Let me see. Here it is. Open. All right. So, okay. Okay. Well, that's best I can do it now. Now we will evaluate the creation. And now we get the feedback here. It largely maintains the original composition of Mona Lisa. Okay, yeah. So as you can see, this is not like super great, but it uses the built-in Prompt API. So let's have a look at this. We go to the source code, go to the JS file, and here we can see that we do the exact same thing. We say language model create. We ask it for a helpful artistic critique, right? That's also why it's so positive. Then we add the images. And then basically we stream back the result. All right. Also new is structured output. In in cloud-based models, also known as JSON mode. Here's a demo that basically uses Prompt API and then expects an output of a certain shape in order to fill in the filters on the left side. And it also shows the multimodal capabilities because we can use speech to filter our flight list, right? So normally you could do it like here, manually, go through this very, very long list, right, of stuff. And now we can ask for, I need a nonstop flight to Los Angeles that is cheaper than $700. Okay, then we can stop it. Now basically we feed in the speech into Prompt API. And hopefully soon, it should update the filters. Yes. cheaper than $700 nonstop, and it's going to Los Angeles. It's all correct. However, I guess the flights are a little bit more expensive. Yes, they are. So they are $758. Yeah, and that's also cool, right? Because now you don't have to click through this entire list anymore. You can simply use your voice in order to filter that list. If you want to play around with those APIs, then just go to About Flags in your Chromium-based browser. Then you need to enable Optimization Guide on device, and then enable the different APIs, Prompt API, Proofreader API, Summarizer API, and so on. Set them to enabled, and then you can use them. The first origin trials are already taking place for Prompt API. So basically, you can even use them without enabling the browser flag. Also, if you want to use them, I built some TypeScript definitions for you. It's obviously not yet in the TypeScript DOM typing. So if you want to use it, then use this npm package, and then you will find TypeScript typings for all of the different APIs that you've seen today. So let's try and add it to our next Angular app. We want to build a smart form filler again that basically extracts data from a larger set of data. So, just thinking. Okay, I guess I will show you the final version because it's actually pretty easy here. Okay, so what I do here is create a contract using a library called Zod. This allows us to basically specify the shape of the expected object. We need that during runtime, and so that's why TypeScript types don't help. Then I get a TypeScript type from it. I set up my signal that contains the name and the city. That's the two data points that I want to extract. And then I create my new signal-based form. And then when I press my button here, I will read the text from the clipboard, create a new prompt API session, and task it to extract the text from the contents of the clipboard. I pass now this JSON schema in, right, from my contract here at the top, parse the result, make sure it matches the JSON schema definition, and then set it in my signal and update my form. So let's have a look at that. I need to stop the other demo and come back here. Okay, so we go to this app, we go to the form area, and now I've prepared some examples. So here in the first case, it's me, Christian Liebel, I'm from Leimersheim. I click paste, and it says, hey, it's me, and I'm from Leimersheim. Awesome. It extracted the info from this large block of text. Let's try it with Mark from Chicago, impressive Duolingo streak, right? Not relevant for the info that we want to extract. We click paste, boom, that's the right response. Now let's try it with Mathieu, living in Grenoble, different language also. We click paste, boom, and the right info is in there. Again, all on device and offline capable. All right, what's next? The next big thing is agentic browsing. And here I have a Perplexity Comet for you, where you can open an assistant and task it with something that you want to do. Oh, okay, we can zoom in. For example, go to bahn.de and find a train from Berlin to Karlsruhe. Now, basically, we send this request, and now this agentic browser, you can already see it, right? It glows, it does the AI glow, so meaning it does something intelligent now. And basically, it will now try to figure out how that website works, and it will try to basically find that that connection for me. But you can see what it does. It takes a screenshot, it clicks stuff, it tries to, what should it do? Berlin is right, yeah? So basically it just tries its way to find to the goal. We will just keep it open in the background. Does it click Karlsruhe? Yes, okay, awesome. And now we want to make that better. And this is where WebMCP comes in. This is a joint effort by Microsoft and Google, and it allows your website to expose tools, so to say an API, to the external agent. And that's how it looks. There's a YouTube video. And I think it's open here, and we will go here. And what Patrick does here is he asks the his Visual Studio Code agent to identify all the to-do comments in his workspace. Right, that's currently happening. Now he finds all of the to-do comments, and now he says, using WebMCP, I want to create a to-do to-do list entry in my app for each of the to-dos that you've identified. Please also tell me the file name, the line, and tell me how to fix it. And then basically, I'm just skipping ahead a bit. So now the agent is working, and now it filled in, it talked to the browser and added the to-dos for all of the tasks, stating the line, the file name, and what you need to do in order to solve your task. Now let's go back to Comet and see if it has found trips. It did, right? So I will likely use that one, right? And it listed all of them for me. I could even ask it to try and buy one and so on. That's all possible. All right, so let's quickly summarize it up. What are pros and cons of Web API? Plus is data never leaves your browser, great for privacy, high availability, also when you're offline, low latency, it's as fast as it can go depending on your device, stability, if you want to change your model provider, basically that never happens, right? Because it's web platform APIs and they never change usually, and the cost is low for you as a developer. Cons. Response quality is lower, certainly. They are a little less capable or always lagging a little bit behind. The system requirements are pretty high. That's why we all needed to buy new iPhones, for example. Model sizes are large, and you cannot always share models. Again, we will see what happens in the future. Model initialization and inference can be slow, again, depending on your device. And all APIs that you've seen today are experimental. And with that, I want to thank you for your kind attention. Thanks for joining, and see you soon.